In this video lecture, I will teach you how to solve linear inequalities. First, what do we mean by a linear inequality? Well, it's a similar concept to a linear equation. And what's a linear equation? Well, we've already learned how to solve those in previous lectures. An example of a linear equation could be 2x plus 1 equals to 7. But what if we want a linear inequality? Well, now I'm going to write a similar equation that is going to represent an inequality. And the whole difference is that rather than having an equal sign, we have a less than sign, a greater than sign, just not equal, not necessarily equal. We could have less than or equal to, or greater than or equal to. Here are all four symbols that we can use in an inequality. This is what sets it apart from a linear equation. Rather than being equal, we have something greater, something smaller, but the methods of solving these are very similar to the methods of solving linear equations. So let's just jump right away into an example. Let's say we have 2x plus 1 is less than 7. So we have the variable x and the constant 1 and 7. And we want to isolate the variable. So we can subtract the 1 on both sides. The inequality remains true because subtracting 1 on both sides doesn't change anything. So we simplify and we get just 2x less than 6. Now we can divide by 2 on both sides because we don't want the 2 in front of the x, we just want x. And again, we're allowed to do this because we've done the same thing to both sides, just like in linear equations. Now we get x less than 3. This is the solution. Now, the solution isn't just x equals to a number. It's rather an interval. So let's draw this interval and then write it down in interval notation. For that, first we're going to draw the number line. And of course, we're going to mark 0. And we want, in addition to 0, 3. Because x is less than 3. So we have x less than 3, so to the left everything works. And the 3 is not included because it's a strict less than sign. So we just have an open circle. That also means when you write down the interval, we're just going to have a regular parenthesis like this by the 3, because the 3 is not included. So the answer could be written as x less than 3, or parenthesis negative infinity, comma 3, close parentheses. So let's take a look at another example. Now remember, I did say that linear inequalities are very similar to linear equations, but there is one distinction that is very important, and I'm about to show it to you. So again, we want to isolate the variable x, so we will subtract a 1 on both sides so that we just have a negative x on one side. Again, we subtracted a 1 on both sides, so it's perfectly allowed. So we get negative x greater than or equal to 1. So now we will learn about this exception in inequalities that I had mentioned. Of course, we want to divide by negative 1 because we just want x, not negative x. So if we divide by -1 on both sides, the inequality should remain the same, right? And this would then tell us that x is greater than or equal to -1. Well, actually, this is false. There's a rule, and this is the difference between inequalities and equations. And this rule states that when you multiply or divide by a negative number, you have to flip the inequality. So in this case, we divided by -1 on both sides. And of course, -1 is less than 0. It's negative. So the inequality has to flip from greater than or equal to less than or equal to. So x is actually less than or equal to -1. This is really important to remember. It's the only difference between when you're equations and when you're inequalities. Otherwise, they're actually just the same thing. So let me highlight again. We've divided by -1 on both sides, so the inequality flipped. It changed the other way. So now we know that the answer is x is less than or equal to -1. So we are ready for the number line. I'm keeping the rule up on the board for now to make sure that you have time to remember it, because it's really the most important part of this video lecture. So we have our number line in 0, and I'm going to make this a little bit shorter so it fits better on the board. And we're going to mark -1 because x is less than or equal to it. And we're highlighting to the left of -1. And because we have x less than or equal to -1, we want to include it. And we do that by making a filled-in dot on the -1. In interval notation, that would be -1 infinity, comma, -1, with a square bracket by the -1 because we're including it in the set. And that is the final answer. So now we'll do one last example to make sure that we understand how to solve linear inequalities. This example will be -3x plus 2 is less than x plus 2. So first, of course, we want to isolate the variable x. So we're going to subtract 2 from both sides of the equation. Now notice, this is the exact same as with a linear equation because we're not multiplying by a negative number, we're just subtracting a number. So this simplifies our equation to -3x less than x. So now we want all the variable x on one side. So we'll just add 3x to both sides. One side simplifies to just 0, and the other simplifies to 4x. Now, to finish off the problem, we divide by 4 on both sides. 4 is a positive number, so the inequality stays the same. So we just have 0 less than x. So on the number line, we just have 0, and we highlight everything to the right, and since it's a strict inequality, we just have an open circle. In interval notation, it'd just be 0 infinity with 2 parentheses. Thank you for watching this video lecture. I hope it helped.